Alright, I'm just going to start going through these questions and then we'll find out, look just where it's at. Okay, the first one, trying to find E1, E2, E3, and E4. This is a series circuit. My applied voltage is 120 volts. Number one, I got to find R total in order to find I total. I total equals E divided by R total. So number one, we got to find R total. Okay? R total is the sum of all resistors in series. 10 plus 25 is 35, and 20 is 55, and 35, that's 90. So our total is 90. E is 120. I total equals 1.33 amps. Okay? To find my voltage, ED equals I total times R. Okay? So we're going to get this 1.333 and then times the 10. So this is 13.33. 1.33 times 25. 25 times 1.33, and that is 33.25. And then 20 times 1.33, and that is 26.67. And 35 times 1.33, and that is 46.67. 67. Okay. So before I do anything, I got to find R total so I can find my I total. This is in series. My current is going to be the same all the way through at 1.33 amps. So if I clank it here, here, it doesn't matter. 1.33 amps. Alright? Next one. So I got a 20 ohm and a 40 ohm. R1, R2, 40 ohm. My voltage is 120 volts. My voltage is 120 volts. Okay, it says R1, so I want I1, and I want I2. Okay, I equals E divided by R. 120 divided by 20, 6. 120 divided by 40, 3 amps. I total is I1 plus I2. So I total equals 6 and 3, 9 amps. So it's asking the current at 1, asking for the current at 2, asking for the total current, and then they want R total. Okay, I got voltage, I got amperage. R total equals E divided by I divided by 9, R total equals 13.33 ohms. Okay. Some of y'all are overlooking this question. You're going way off base. You're going way off base. Okay. I can get R1 times R2, R1 plus R2. It'd be 20 and 40 and 20 plus 40. So this would be 20, so that's 800 divided by 60. Okay, you're going to come back to that 13.33. Okay, but if you have voltage and total current, this is the easiest way to do it. R1, R2, 5 ohms, 10 ohms, oops, 15 ohms, I'm sorry. 15 ohms and 20 ohms. Okay, here, these are in series. We need to find our total. 5 plus 15, our total equals 20 ohms. I equals E divided by our total. We're only talking about this one right here. We're only talking about this one right here. Okay, so our voltage is 12. So now we get 12 divided by 20. I equals 0.6. Get my calculator. So 12 divided by 20 equals 0.6 amps. Okay? I come over here. I equals E divided by R. 12 volts divided by 20 ohms. I equals 0.6. It's the same. 0.6. Okay. My total current. Okay. 0.6 plus 0.6. I total equals 1.2 amps. 0.6 plus 0.6. I total equals I1 plus I2. Here's I1. Here's I2. Okay. Find the simple things. Always try to find. Here because this is series, we need to find our total because we got to find the only way we're going to find the current is that we have to find our total. Okay. This is our total for this branch. This branch is only one circuit. Okay. Now, our total for the whole circuit, our total equals E divided by I total. Okay. Our total equals 9 divided by 1.2. I'm sorry, 12. Not 9, 12. Our total equals 10 ohms. R total equals 10 ohms. Okay. I can do it this way. R1 times R2. I'm eliminating this. I'm making this R1. So R1 here is 20 ohms. R2 is 20 ohms. So I can do the 20 times 20 and 20 plus 20. So 400 divided by 40 equals 10 ohms. Okay? There's another way I can do it. Take the resistance of 1 divided by the number of resistors. Okay? R total equals R of 1 divided by the number of R. R of 1 is 20. Why? This is 20. This is 20. 20, I got 2. So 20 divided by 2, R total equals 10 ohms. Okay, I just did it 3 different ways. There's a 4th way I can do it. I'm not even going to get into the fractions. Okay? Don't overthink it. When you start overthinking the question, you get confused and lost. Look at the simple things. Try to find the simple things. That's one I just did. Okay. So I got volts. I got the watt meter. And I got the amps. Okay. So my volts is 240 volts. My amps are 14 amps. You want to know what the watt meter is reading. Okay. So they got a power factor of 8.875. Okay. Formula's easy. I want to find what my true power is. Because my meter is reading the apparent power. So all I'm going to do is 240 times 14 times 0.875. And that'll be 2,940 watts. Okay? Thing is, it's my true power is the 240 times the 14. My apparent power is 2940. So going back, so our true power is this. Our apparent power is 240 times 20. If I divide this by this, it's less than 100%. Okay, so my apparent power is voltage times the amperage. It's whatever the voltage and the amperage are. And true power is what's there with the factor. They don't want us to pay the utility. See, this is what we're paying. But we're using 240 times 14 amps is, I'll use my calculator. 240 times 14 16 equals, see, this is what we're using, but we're only paying for this, okay, because of our power factor. So this is what we're paying for, but we're actually using this. Okay. All right. Okay, so the diagram's like that, which is actually more conventional that way. Same drawing. So this is R1, 8 ohms, R2, 16 ohms, R3 is 20 ohms, R4 is 52 ohms. So this is 8 and 16 and 20 and 52. Okay, R1, R2, R3, R4. Our voltage is 9 volts. Our voltage is 9 volts. Alright, first I have to find our total here. Our total, 8, 16 is 24 ohms. Here, our total is 20 and 52, 72 ohms. Okay. So this is B1, B2, B1, B2. Okay, branch 1, branch 2. I want to find my amperage here. I1 equals E divided by our total, 1. I2 equals E divided by our total, 2. Okay, we'll come back up here. We'll go to the top. So it's going to be 9 volts. 9 volts divided by 24. Okay, 9 volts divided by 72. This is I2, and this would be I1. Oops, 9 divided by 24 equals 0.375. 9 divided by 72 equals 0.125. Okay, I total equals I1 plus I2. I total equals 0.5 amps. Now they want want to know the voltage drop across 1, voltage drop across 2. Okay, so ED equals R1 times I1. Here, since this is the ED1, ED2 equals 16, which is R2 times I1. And down here, ED3 equals, this is R3 times I2. ED4 equals 52 R4 times I2. So here it's E equals 3 volts. Here E2 equals 6 volts. I'm sorry. $6. 20 times 0.125, ED3 equals 2.5 volts. 52 times 0.125 equals ED4 equals 6.5 volts. Okay, so it's looking at the picture, not getting confused. Yeah, our total. I got I total. I know what my I total is. I know what my E total is. Our total equals E total divided by I total. Our total equals 9 divided by 0.5. This is volts, amps. Our total equals 18 ohms. Okay? It's very simple. Very simple. Is breaking it down. This is series. This is series. Parallel to each other. Okay, so this is going to have its amperage. This is going to have its amperage. Okay? That's circuit. They just drew it funny, but the same thing. Okay, R1, R2, R3, R4, R5. We're trying to find R5. So this is 4 ohms. 4 ohms. Okay, we have 24 volts. And I total equals 4 amps. So here it's 8 ohms, 10 ohms, trying to find R5. Okay, so here we know what our total amperage is, we know what our total voltage is. Okay, now we have to find the resistance for here. Okay, always try to find the amperage. So let me close this one out so I already know. I already know what is there. So our total equals R1 plus R2, 8 ohms. Okay. I total 1. I'm going to call it 1. So this is going to be branch 1, branch 2. Okay. I1 equals E divided by R total 1. So 24 divided by 8, I1 equals 3 amps. So my I total is 4. I2 equals I total minus I1. So 4 minus 3, I2 equals 1 amp. Okay, so I got 1 amp going across here because this is using 3 of the 4 amps. This branch is using 3 of the 4 amps. Remember, the lower the number, more amps. The higher the number, the less amps. Okay, now I can find our total down here. Our total equals E divided by I total. Okay, I got I total now. I got 1 amp. 24 divided by 1. Our total equals 24 amps. 24 ohms. Equals 24 ohms. Okay? Here. So now it's just a matter of 24 minus 10, 14. 14 minus 8, 5. So R5 is 5 ohms. So my answer is 5 ohms. My answer is 5 ohms. Okay? Just going through the steps and finding. You're just working in reverse back. You're just working in reverse back. Okay, the last one. I'm just going to draw it simpler. 1, 2, 3. Okay. R1, R2, R3, R4, R5, and R6. Good. 1 ohm, then it's 2, 3, and 5. 2 ohms, 3 ohms, 5 ohms, 40 ohms, and 3 ohms. Okay? Always go to the end. Our applied voltage is 120 volts. Go to the end. Find your total resistance of what's in parallel. These are in series. These are in series to each other and parallel to the 40. This one and this one are in series to everything else. So 2 and 3 is 5, and 5 is 10. Our total here equals 10 ohms. So I'm going to make this temporary R2, and this R3. So R2 times R3 divided by R2 plus R3. So this would be 40. That's 10. And this is 40. And that's 10. So 40 and 10 is 400. 40 plus 10 is 50. That equals 8 ohms. So I just broke in a resistor here, and I made this 10 ohms. I'm sorry, 8 ohms. Okay, 8 ohms. Now my R total, because I equals E divided by R total. Total to the circuit. So 1 and 8 is 9, and 3 is 12. So 120 divided by 12, I equals 10 amps. So my whole circuit, I have 10 amps. ED equals I times R. Okay, ED equals I times R. So 10 times 1, so I got a minus of 10 volts. 3 times 10, 30 volts. 8 times 10, 80 volts. So I got 80 volts because these are in parallel. I got 80 volts going across here. I got 80 volts going across here. So as my voltage goes across, so I get 40, my current's going to change. My current is 10 amps. So I got 10 amps going across here, and I got 10 amps going across here. When I come to here, my amperage is going to change. I got so much coming this way, and I got so much coming that way. Okay? I equals E divided by R. Okay? 80 on this one here, 80 divided by 40, 2 amps. 80 divided by 10, so I got 8 amps. Okay, now I know what my amperage is across each resistor. Now I can find the voltage drop at each one. Why? Because I got 8 amps. I got 8 amps of the 10 amps going through this branch, and I got 2 amps of the 10 amps going through this one. Okay? Because the voltage drop, when voltage comes across, my voltage gets to here, it's at 0 volts. When it gets all the way through here, at here, I'm at 0 volts. So now, 8 times 2, 16 volts. 8 times 3, 24 volts. 8 times 5, 40. Okay, 16 and 24 is 40, and 40 is 0. So my voltage drop across here is 16 volts. Voltage drop across here is 24 volts. Voltage drop across here is 40 volts. Okay, because my voltage drop is I times R. I times R, very easy. I got my I total. I can make this I total, because that's my amperage through the whole circuit. I'll never have more than 10 amps. And because these are in parallel, they're splitting the amperage between both of them. They're splitting the amperage between both of them. Okay? But this is going to get its voltage, that's going to get its voltage. And this would have 80 volts going through it, and this would have 80 volts going through it. The answers will be in this video, and I'm moving on. You know, go back and figure out, look at the video till you get it. Okay, there's now going to be 4 videos. So you got the series video, you got the parallel video, you got the series parallel video, and then you got the answer sheet video. Okay, and I'm moving on. We got to keep going now. So go back and look at it till you try to get it. And again, it's just trying to see it simple. You know, take the binders off. Look at the whole picture and don't get stuck in one area.